Hello, my math team freshmen. Today we are going to be talking about number bases. So I have developed a group of short videos to help you through some of this new content. So first of all, you have some things that you can look up on YouTube that can be helpful. So you can do that on your own time. The first thing we're going to talk about is which numbers we use in different bases. So base 4, this means use 0, 1, 2, and 3. Whatever base you're in, you cannot actually use that number. So these are the only 4 digits that you can use. Base 9, you use 0, 1, 2, 3, 4, 5, 6, 7, and 8, but again, you cannot go up to 9. Base 14, we can go all the way up to 9. We don't use 10. Okay, 10 isn't a number we use in base 14. We use letters to go into 2 digits instead. So A is representing like our 10 value, B is 11, C is our 12, and D is our 13. So when we're doing computations within a given base, these are the only numbers that you can use. All right, so let's go ahead, let's try converting to base 10. This is the first thing. So right now this is in base 5. We're going to convert to base 10, which is kind of our standard base that we normally use in, our everyday lives. So what you're going to go ahead and do is go farthest to the right, and whatever base you have, this is going to start with that base to the 0 power. So this is our 5 to the 0 power. Again, this is a little weird, just bear with me. This one we're going to label 5 to the first. And this one is 5 to the second. So always start from the right, and then what you're going to do is you're going to multiply the number times this thing here. Okay, so it's going to look like this. It'd be 2 times 5 squared, so that's the yellow, plus 1 times 5 to the first, plus 3 times 5 to the 0. Okay, and then this is a non-calculator test, so you should do these without a calculator. So this would be 25 times 2 is 50, plus 5, plus 3, and so 58 base 10 would be your answer. Okay, and this is just the 58 that we know in our everyday life. Okay, let's try it again. This one is base 2. This is called binary. We're going to talk about that in another video, but for now we're going to do it this way. So again, this would be 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. Okay, so we're going to do our 1 times 2 to the fifth, plus another 1 times 2 to the fourth, plus a 0 times 2 to the third, which technically you can get rid of since that's a 0, plus 1 times 2 to the second, plus 0 times 2 to the first, which again we can disregard, plus finally our last one times 2 to the 0. And then we're going to go ahead and evaluate that. This will be a 32 plus 16 plus 4 plus 1. And that should be 53 base 10. All right, so now let's try what happens when we have letters that get involved. Okay, so A here is like our 10. All right, we're in base 16 here. And so again, this is going to be your 0, 1, 2. So we're going to do 1 times 16 to the second, plus 10 is what we're going to put for A, times 16 to the first, plus 2 times 16 to the 0. And then 16 squared is 256. This is going to be plus 160 plus 2. And so if you evaluate that, you're going to get 418 base 10. All right, so you can go ahead and try number 4 if you would like, or if you feel like you've got the hang of it, you can skip to the next video. I'm just going to go ahead and remind you that B would be 11 here. And I also will give you your final answer just so you can check your work if you choose to do this. It should be a 744 base 10. Okay, all right, so this is how we convert to base 10 from a different base, and go on to your next video.